Hey everyone, welcome back to another video for AP Pre-Calc. Today we're going to be going over the Unit 2A exam review. Let's get right into it. All right, so first off, a set of data was used to create a linear, a quadratic, and an exponential regression model. The residual plots are shown above. Based on the residual plots, what is the most appropriate model for the data? So here it is important to note that these are residual plots. These are not plots of the actual data points. They're plots of how far off each data point was from the actual value. And that's what a residual is. With residual plots, all you really need to know is random is good, right? If we see a random residual plot, then that means that model is a good fit. It's very appropriate for the data. And so the most random residual plot is the linear regression model, this one. This one and exponential regression models have a clear pattern within the residual plots. So here I would put linear regression model. And that's because the pattern of the residuals are random. Number two, let f be an exponential function with the following end behavior. Here, let's sketch a possible graph of f. So we know the limit as x approaches negative infinity. As we go to the left, this is approaching negative infinity. And the limit as x approaches positive infinity is approaching 0, right? It's going to get closer and closer to 0. So a good exponential function should be one that kind of looks like this. It's always going to be increasing. This one should always be concave down. But as we go to the left, it's shooting down. And as we go to the right, this is going to get closer and closer towards 0, but not touch it. All right, number three, which of the following statements about exponential functions is true? If you only have 1 point, you can write the equation of an exponential function. That is not true. You need at least 2, so this should be 2. So we can eliminate A because that's false. B, arithmetic sequences behave like exponential functions. That is also false. This should actually be geometric. So B is false. C, the change in y, right? You're changing your y values. If you have an xy table, for example, your change in your y values is going to be based on multiplication. That is true for exponential functions. So C should be our answer. Taking a look at D, over equally length input value intervals, the output values change at a constant rate. This is wrong. This should be change, and then the word that we taught that we used in class is proportionately. So D is false as well, making C the correct answer. Number four, consecutive terms have the values negative 64, negative 32, negative 16, negative 8, negative 4 for a sequence. Fill in the following to best describe the sequence. So here, just taking a look at these terms, right, we see negative 64, minus 32, minus 16, and it's pretty easy to tell that this is going to be a multiplication rule, right? If you try adding the same number, right, this would be plus 32. If you continue that, it's not going to work. So it's probably going to be geometric. And what do we multiply 64 by to get negative 32? To figure this out, you could always put the second term over the first term and then simplify that, and that's your common ratio. That's why we call it a ratio, because it's a ratio of negative 32 over negative 64. This simplifies to 1/2, so that should be our common ratio here, which makes sense, right? Each time you go to the next number, you're basically dividing by 2 or multiplying by 1/2. So here, we're going to say these terms could be part of a geometric sequence with a common ratio, and that always pairs with geometric and then in this case, we found that that was 1/2. So that should be our answer to number 4. Number 5, an exponential regression was used to develop a model for a set of data. The figure shows a graph of the residuals of the exponential regression. Is the model appropriate and why? And so this actually comes from that graph from question 1, but this would not be appropriate because there is a clear pattern in the residual plot. So we should say no. And then for our explanation, because it asks why, there is a pattern in the residuals of the exponential regression model. Right? So in the residual plot, we see a pattern, and that's why it's not appropriate. Number 6, 7, and 8. This is all pretty much the same thing. This is going to be covering lesson 2.4, exponent or exponential manipulation. So here we're going to just rearrange it in the form a times b to the power of x, where x is pretty much by itself in the exponent. So taking a look here, we can split up that 5 to the power of x plus 2. Remember, if you have a to the power of b plus c, we can chop this up into a to the power of b times a to the power of c. So we have that 2 out front. That's not really going to change. And then we're going to split this up into 5 to the power of x times 5 squared. This would be 2 times 5 to the power of x times 25. And then we can combine this into just get a single number. So this should be 2 times 25 is 50 times 5 to the power of x. And that should be our answer for 6. For 7, here, because it's multiplied, if we have a to the power of b times c, we can actually rewrite this and change the base into a to the power of b, and then that whole thing in parentheses to the power of c on the outside. So let's do that with the 2 to the power of 3x. That should be 5 times 2 cubed, and then we're going to put usually the x term on the outside. So this should become 5 times 8 to the power of x, and that should be our answer. All right, number 8, same thing here, except instead of 3, we're going to put negative 2. So this should be 2 times 9 to the power of negative 2, and that whole thing to the power of x. So pretty much the same thing as 7, but we can simplify the base a little bit more. So remember, with negative exponents, you have 2, and then we can move this to the denominator, 1 over 9 squared, and still that whole fraction is still to the power of x. Then we can simplify this just a tiny bit more, 2 times 1 over 81 to the power of x, and that should be our answer there. Number 9, the first term of an arithmetic sequence is negative 5. The common difference is negative 2. What is the 8th term in the sequence? So here we are given a of 1, our first term, is negative 5. Our common difference, d, is negative 2. And we are looking for a of 8 is what we're looking for. So I would write out our general equation, a of n equals a of k plus d times n minus k. Once we have this, we're going to plug in what we know. Here, we have our d, so that's pretty easy. We need to set one of these to a of n and one of these terms to a of k. Remember, k comes before n alphabetically, which means a of k should be the term that comes before a of n. We have our first and our 8th term, so our first term should come before. So that's going to be our a of k, and this should be our a of n, which will typically be our later term of the sequence. Once we have this, we can also pull from these that a of k is different. So a of k is very different from just k here. These two are very different things, so be careful of that. In this case, a of k is going to be negative 5. But here, we should just have k to be 1. And then n should be 8. So that's based off of our subscript. Now plug in everything you know. So a of 8 equals negative 5, which is a of k, minus 2, which is our common difference, and then 8 minus 1. And now we're just solving to find our 8th term. So simplify this. Make sure you do order of operations correctly. So do the multiplication first. So negative 5 minus 14. And then this should become negative 19. And that is going to be our 8th term in the sequence. Should be negative 19 there. Number 10, the values of the functions f and g are given by the table. Let h be defined as the inverse of g, and then f, and then g of x. What is h of 9? So this is going to be the inverse of g of f of g of 9. So let's take this step by step. We want to work from the inside out. So what is g of 9? G of x, when x is 9, should be -6. So this should then be the inverse of g of f of -6. And now we want to find what is f of -6. That is going to be 7. So f of x when x is -6 should map to 7. So this is going to be the inverse of g of just 7, which is, where is now g of x just equal to +7 in the y values, because it's the inverse. We're going the opposite direction, and that should be correlated to 8. So 8 should be our answer for number 10. Number 11, students are an invasive species in my class. The population increases on an average of 7% per day. So I'm going to make that note, 7% per day. It's important to know our unit of time there. Let 900 be the number of students I start with. What is a function that models the number of students? T weeks. So here our unit is weeks, not days, where 900 is what I start with. So here let's write g of t equals, and then it's going to be an exponential function in this form. So a should be our initial amount. So this is just going to be 900. And then our base is going to be our growth rate per our unit of time, which is weeks. So what is our growth rate for 1 week? That's going to be, if you increase 7% per day, right, each day you multiply by 1.07. So let me do that here. Each day we multiply by 1.07, and you're doing that 7 times over the course of a week. So then over the course of 1 week, you're basically multiplying it by 1.07 to the power of 7. So that is going to be our growth factor. And then to the power of t weeks, we can even rewrite this as g of t equals 900 times 1.07 to the power of 7t, and just move that 7 out and multiply it to t with the exponent rules that we've learned before. All right, so for number 12, a new student organization is spreading to different universities across the US. When it was first founded, 4 universities participated, and then 1 year later, there was 20 universities participating. If an exponential function is constructed to model the number of universities, how many would the model predict at t equals 2 years? So this is going to be basically kind of working off of a table, right? We want to figure out how many should there be in year 2 if we know that we are using an exponential function to model it. So with an exponential function, remembering from lesson 2.2, here over equally spaced input values, which these are because they're both spread apart by 1 year, the output values will change proportionately, meaning whatever number we multiply 4 by to get 20, we can do that as well to find how many universities should be at 2. In this case, it should just be 5, so times 5 times 5, and this rule would continue, times 5 times 5. So this should be 4 times 5 is 20, 20 times 5 should be 100, and so 100 should be our answer here, 100 universities. Number 13, the function g is defined by g of x equals 3 to the power of x minus 3. This is working off of the transformed graph of just that parent function f of x equals 3 to the power of x. Which of the following would describe this transformation? So if we take a look at this equation, right, here we can say g of x, which is 3 to the power of x minus 3, is equal to, in terms of writing the transformation, f and then x minus 3 on the inside, right? Because we plugged that basically in for x in f of x there. This is going to be then 3 to the power of x minus 3, which was the equation for g of x. And this transformation, we would describe this as a horizontal translation of, and now this is the key, plus 3 units, not minus 3. So it's not going to be A. Now let's take a look at how, then if it's not A, then how are we going to get the correct answer? Let's manipulate this equation. So if we have 3 to the power of x minus 3, we can rewrite that as 3 to the power of x times 3 to the power of negative 3, which is 3 to the power of x times 1 over 3 cubed, which is 3 to the power of x times 1 over 27. And this is now a transformation that is working off of the parent function 3 to the power of x. With that number 1 over 27 multiplied out front, this is now going to be a vertical dilation by a factor of 1 over 27. And that's the key here. And so D should be our correct answer. B and C would also be incorrect there. Number 14, the function g is an exponential function that increases, so it's going up, at an increasing rate. This means concave up for all values of x. Which of the following statements could describe the end behaviors? So this graph it's going up and it's concave up. So a concave up function looks like this, but we only want the part of the function that is increasing, so we can erase that part right there, and that's going to be our exponential function, like this. So writing our two limit statements, we could write the left-hand one as the limit as x approaches negative infinity of g of x, and this is going to approach 0. And then here we have the limit as x approaches positive infinity of g of x should equal positive infinity there. So that should be our answer to 14. 15, the graph of the piecewise function is shown in the figure. Sketch the inverse function, and then what is the inverse of 3? So sketching our inverse function, what we want to do is take note of all of our points. So we have negative 3 comma negative 4. You got 1 comma negative 2. You got 3 comma 2. And then you got 5 comma 4. And to sketch your inverse function, just simply flip the coordinates. So negative 4, negative 3, negative 2, 1, 2 comma 3, 4 comma 5. There. And now graph what you can. So here you almost have to extend this a little bit, but 4 comma 5 should be right there. 2, 3. Let's see, negative 2, positive 1, and then negative 4, negative 3. So connecting the dots here, that's what we should get, which if you take a look and sketch it out, it's a perfect line over the reflection of y equals x there. So this looks good. And then if we want to find the inverse of 3, what you would do is you could either do this one of two ways. You could plug 3 into the x value and find your corresponding y value. That's right there in the inverse function and get 4. So h inverse of 3 equals 4. Or what you could do, which might be a little bit quicker, is without even sketching the inverse function, if you're working off of your original function, here you look at 3 as your y value, and then you should get 4 as your x value here. So either way, you'll get the correct answer. So that's the answer for number 15. 16 here, a regression model is used to construct or model the relationship between an input and output variable. The residuals are plotted and labeled. A has a residual of negative 2.4 and B has a residual of positive 2.3. Is A or B the overestimation? And then which input has the largest error? And so an overestimation, remember, is a little bit inverse. Overestimation will come from a negative residual, and then an underestimation will come from a positive residual. So it's a little bit inverse. So here our overestimation should be from A. So A is the overestimation. And then the largest error is just the absolute value of the residual. So here for our error, the absolute value of negative 2.4 is just 2.4. And the absolute value of positive 2.3 is 2.3. So this is larger. So A has the largest error as well. So that should be our answer for 16. All right, so for question number 17, we're asked what is g of the inverse of f of x? And so we want to find the inverse of f of x, and then we're going to take that whole equation and we're going to plug it into g of x. So the first thing we want to do is find the inverse of f of x. So let's replace f of x with y equals 1/4 x. Once we have this, we need to swap x and y, and then we are going to solve for y. So to do that, to get y by itself, we're going to multiply both sides by 4. Then we can cancel those out. We're left with y by itself on this side, and then 4x, and then just rewrite it using the correct notation. So the inverse of f of x is equal to 4x. So because this is 4x, we can rewrite this as g of 4x, which g of x is just x squared, but now instead of x squared, it's going to be 4x squared. Remember, when it's two items multiplied by each other, you can square both of them. So this just becomes 4 squared times x squared, which should simplify to 16x squared, and that should be our answer there. All right, now for the short answer. These are the two questions here are going to be ones where you have access to Desmos for, so let's use Desmos when we work through these questions. So first we want to find h of 8 when h is a composite function. So h of 8 is equal to g of f of 8. Then we want to start from the inside. So what is f of 8 from the graph? Well, when x equals 8, then that's going to be this point right here, which has a y value of 2. So this is really just going to be g of 2 here. And to evaluate this, you can do it multiple ways, but the way I like to do it is type in your equation for g of x in Desmos with the g of x part. Then we want to find g of 2, so literally just type in g of 2. It will then plug 2 into that exponential equation for x and spit out your output. So our answer should be 26.2899, which is going to be rounding to 3 decimals, 290, or you could have 26.289. Either one would be acceptable. And so this should be your answer here. In terms of what else I want to see on a test, I also want to see that middle number 2 somewhere in your work as well. Part 2, find all values for x for which f of x is equal to 4, or indicate that there are no such values. So here we want to now, this is dealing with inverse functions, we want to see where is f of x equal to 4, and that's going to be at this point right here, where this is where x equals 3. So that should be our answer there, x equals 3. That's our only point, so that will be our answer for 1A, part 2. The second part, part B, 1, find all real zeros of g, or indicate that there are no real zeros. If you take a look at that exponential graph here, this exponential graph is actually a typical exponential graph. However, it's shifted up 5.1 units. As a result, an exponential graph would approach 0, right? Would get closer and closer to 0, but never touch it. However, when we're shifting the entire graph up 5 units with that vertical translation, it will still never touch 0. So here we would say no real zeros for that one. And that is where you use Desmos to kind of look at the shape of the graph and see where it touches 0. For part 2, determine the end behavior of g as x increases without bounds. Express your answer using the mathematical notation of a limit. Here we're still looking at that exponential function, and we want the limit as x increases, so as x approaches positive infinity of g of x. So make sure you have the correct function. If you have f of x, it will be marked wrong because I will be asking about g of x, equals, and then as we go to the right forever for this function, our y value is approaching a straight line of, it typically, like I said before, should be 0, but with that vertical translation, this is actually approaching 5.1. So that should be our answer for the second part of B there. Okay, part C, determine if f is invertible and then give a reason for your answer based on the definition and reference specific points. So here, all you need to do is kind of just use that horizontal line test. This does not work, so we're going to say no, f is not invertible. And then what is a reason for that? Well, we can reference two specific points that break this horizontal line test. Obviously, there's a lot of things that break it, but two integer points that I see that you can use are 2, 2 and 8, 2 here. So for my answer, I first want to talk about the definition of invertibility. So I want to say f specifically is not 1-to-1. That talks about the definition, and then you can say, and you could say, let's say 2, 2 and 8, 2 have the same y value. And that is a perfect explanation for C. That would get you full credit. All right, so for question number 2, we're given a context of a story problem. Here, it's talking about Marie Curie and a group of scientists studying radium. We are given that after 2 days, there was 3.42 grams of radium left, and after 11 days, there was 1.79 grams left. We are given that the amount left, it can be given by an exponential function r of t in the form of a times b to the power of t. So you do need to be cognizant or aware that this is an exponential function because that is in the form where the exponent has a variable in it. A lot of people on the last exam, I gave them the form at squared plus bt plus c, and they were so puzzled and had no clue what type of regression model to use when it clearly is a quadratic regression model because it's a quadratic equation. So you should be able to identify that on a test. Now let's answer some of these questions. You will have Desmos for all of these. Use the given data to write two equations that can be used to find A and B. In part A1, we are not solving for A and B just yet. Taking our 2 points that we are given is 2, 3.42, and then 11, 1.79. This is very similar to y equals a times b to the power of x. So we can plug in our x, y coordinates in for x and y there, because we were given our x variable is time t, and our y variable is the amount of radium left. So plugging this in, we should get 3.42 equals a times b squared. You can just leave it like that. And then 1.79 equals a times b to the power of 11. So that is perfect there. That's our answer to part A. Part A2, find the values of a and b as decimal approximations. All you need to do here is add a table in Desmos. So add table. And then you want to plug in your 2 points in for x and y respectively. And then in the dropdown, pick exponential regression. So that's why you need to identify that it's an exponential equation. In your equation, this will actually give you your values of a and b. In this case, a should be equal to 3.949, rounding to 3 decimal places, and b should be equal to 0.931. So those would be our answers for part A2. All right, question number 2. Part B, use the given data to find the average rate of change from 2 to 11 days. Express your answer as a decimal approximation. Show your work. So here our 2 coordinates again were 2, 3.42, and then 11, 1.79. We're going to plug this into our slope formula because that's what average rate of change is slope. It's y2 minus y1 over x2 minus x1, which, plugging it in, should be 1.79 minus 3.42 all over 11 minus 2. Here we should get as a decimal approximation negative 0.181 repeating, so that would be our answer, just rounding to 3 decimal places there. All right, part 2, use the average rate of change found in part 1 to estimate the amount of radium. after t equals 15 days. So we want to use our slope from part 1 to help us and assume that our 2 points, right, we had those 2 points there, we're going to form like a straight line and use that to predict how much is going to be left at time t equals 15. What's like that y value? So here we're going to use point slope form. So y2 minus y1 equals m times x2 minus x1. Here our m from part 1 was negative 0.181. And here you're just going to keep all those ones and use all the decimal places you can. Here our x1 comma y1 should be one of these 2 points, any one of those two, but it has to be one of those two that you used in part B1. So here we'll just do easy, we'll keep it easy, 2 comma 3.42. And then here our x2 comma y2 should be 15 comma, and then we'll leave this as y2 there. So this is y2 and then this is 42 there. And the reason why is because we need to find the y coordinate when x is 15. If we just plug in the other point, 11 comma 1.79, there's nothing to solve for. So let's plug it in now. So we have y2 minus our y1, which is 3.42, equals negative 0.1811 times 15 minus 2. And then we want to just plug this into Desmos, and we should get y2 is equal to 1.065 repeating. So you can just leave that, or you can round to 1.066. Should be our answer for B2. All right, so for part 3, here, let A of t represent the estimate for the number of, or the amount of radium using the average rate of change that we just found. So drawing a more generalized example here, right, we were given 2 data points, and then we had an exponential decay function, and then we had a straight line approximation. And this was between 2 and 11, and then we found our estimate for like 15, maybe right there. For a of 15, it can be shown that a of 15 is going to be lower than r of 15, that exponential function. Explain why in general, anytime you go past 11, where t is greater than 11, so we're going to have almost like tunnel vision and focusing only on this area right here, that blue area is what we want to focus on. Why is that straight line below the exponential function? Explain why and reference the graph of r and its relationship to a of t. So this is going to be one of those cookie cutter answers. Our answer should be a of t is just less than r of t, when t is greater than 11. So basically just repeat that, like copy and paste almost. And then, let me erase that. And then for our reason why, we want to say, talk about the concavity of r of t. So this is r of t right here. So we want to say because r of t is concave up and the secant line, and this is important, from t equals 2 to t equals 11. So you want to say where the points of the secant line come from, right? What 2 points are we using to form that secant line? So this is all one object. The secant line from t equals 2 to t equals 11 is below r of t. And that would be a perfect explanation where you have both things that I'm looking for. You talk about the concavity of r of t, and then you also address the secant line that's formed between the points 2 and 11. All right? And now the final one, for which value t equals 6 or t equals 19 days should the scientists have more confidence in when using the model R? Give a reason for your answer based on the context of the problem. So here, if we had 2 and 11 here, and we had our exponential decay model like that, which one are we going to have more confidence in being right? 6, that's in between here, or 19, that's like way outside the range. I'm always going to give you one value in between the 2 points that I give you and one value on the outside. The answer should be the value on the inside, so t equals 6. because t equals 6 is within the 2 data points we were given. And then I want you to say that it's between the 2 points that you were given, which was 2 and 11. So given t equals 2 and t equals 11, or you could say like t equals 6 because t equals 19 is not within or not between 2 and 11, or because t equals 6 is between 2 and 11. If you have any questions, please let me know, and I will see you guys later.